Right, we'll conclude this section talking about limits at infinity and the difference between that and what we've been doing so far. So we're going to think of infinity in a different way here. So you might recall end behavior. You studied that in college algebra. That's really exactly what we're going to be doing um, now, but we're just going to really think of it in a slightly different way. But it's exactly the same concept. End behavior, that is what happens as x approaches infinity and as x approaches negative infinity. So what happens at the ends of the graph to the far right and to the far left? What's the y value doing as x shoots off to infinity or back to negative infinity? So a quick example here to just kind of hit what you would have done back in college algebra, more or less, in a few words. So let's say we had the function f of x equals 4x squared plus 3x plus 1 all over 2x squared minus x plus 3. Okay. What is the end behavior there? And well, we have to think of it in both directions. And the trick is you can focus just on the highest powers of x in the numerator and in the denominator. And I like to circle them. So the terms with the highest powers. So that's the 4x squared and the 2x squared. And what you can do then is simplify that, right? So 4x squared over 2x squared, well, the x's would cancel and the 4 divided by 2 would just give you 2, right? So it turns out as x gets really, really big, this function tends towards 2. Why is that? Well, without going through, maybe all the details, as x gets bigger and bigger, x squared dominates the numerator, right? When x is a really big number, x is actually very small compared to x squared. And certainly the plus 1 is very small compared to the x squared term. And the same in the denominator. The x squared term is so much more influential than the x here or the plus 3. So we can just focus on those most influential pieces and then just do the ratio of those. So what would we say? In this case, y equals 2, think of the horizontal line. Y equals 2 is a horizontal asymptote. The function is going to tend towards that asymptote in both the positive and negative directions. Well, how does that connect to what we're doing if thinking about limits? Well, end behavior, I mean, you even see it in this notation, which you might very well have used back in college algebra. If we were to do the limit as x approaches infinity for that function, we could again just focus on those highest powers and reduce there. The answer to that limit is going to be 2. As x gets bigger and bigger, that function approaches 2. You could say the same thing as x approaches negative infinity. That's going to be 2 there as well. Okay, so now what kind of examples are we going to get? How are they going to be phrased? That sort of thing. Determine the limit at infinity. And it's really just this idea of picking out the highest powers of x and reducing them. I'm sorry, my exponents are maybe a little bit tiny on the screen. Okay. Here we go. Let's do the limit of this 5x to the third minus 1 over 8x plus 3, and it's as x approaches infinity. Well, what are we going to do with that? So we look at the ratio of the terms with the highest degree. So that's the 5x squared and the 8x. They can be different. They don't have to be the same power on x. Just the biggest one in the numerator and the biggest one in the denominator. So we'd say, okay, if we reduce here, then we're talking about the limit as x approaches infinity of 5x squared over 8. We would cancel out one of those x's. Okay. And now we're going to think, all right, at this point, we haven't, not all the x's canceled out, so we don't have an answer yet. So now we can plug in. If we plug in infinity, what's going to happen? Well, what's infinity squared? If we plug the infinity in, well, infinity squared is just a bigger version of infinity. And then multiply that by 5, right? Divide that by 8. It's all going to work out to simply be infinity in the end. Well, what does that mean? It means that, well, we've answered the limit question, but if we're thinking like as far as horizontal asymptotes, this function would not have a horizontal asymptote. The y value is just shooting up and up and up, curving up and up and up maybe, doesn't ever level off. Okay. Let's look at another one. Hey, how about the same function, but now let's say x approaches negative infinity. Ooh, that'll be good. Well, we're going to begin the same way. We look at those highest powers and we simplify them. Okay, so it's the limit as x approaches negative infinity for 5x squared over 8. If we plug in negative infinity, what's going to happen? And you notice the negative is going to get squared, and these other numbers are positive. We're still going to get positive infinity. So even as we go back to negative infinity, the y value shoots up and up and up. Okay. And I think this is the last one. Part C. We have the limit as x approaches infinity, 3 plus x plus 2x squared over 5 minus 3x to the fifth. Well, we'll take the biggest powers, so we have positive 2x squared. Don't forget the minus sign here, negative 3x to the fifth. And so this is going to be the limit as x approaches infinity. Now here the power on x is bigger in the denominator, so when we reduce, we're going to have, let's see, 2 over negative 3x to the third. So when we plug in infinity, oh, what is going to happen here? Now this is interesting. If the power in the denominator is higher, then we still have some x's here in the denominator. If we plug in infinity, then the denominator is getting bigger and bigger and bigger. The denominator is negative infinity, right? So what is 2 divided by negative infinity? Well, let me just tell you the answer and then maybe try to explain. The answer here is 0. The y value of that function is getting closer and closer to 0. And here's my explanation. I wrote it down. Think of it this way, that the denominator is getting very big. So we think of, sometimes it's handy to think of plugging in infinity. Other times it's really more appropriate to just think, it's not that we're plugging in infinity, it's that x is getting closer to infinity. So x is getting larger and larger and larger. Well, as x gets larger and larger and larger, this denominator gets bigger and bigger and bigger as well. Right now it's negative, but it's getting to be a very big negative number. So what happens if you take 2 and divide it by very big negative numbers? Well, every time you do that, you're going to get closer and closer to 0. So hopefully that clicks with you, that as x is getting larger here, the value of that whole thing is getting closer and closer to 0. Now, if you wanted to connect it to a horizontal asymptote, we would say, these answers were infinity, so they don't have one, but now we got a number answer. Y equals 0 is a horizontal asymptote for this function here. Okay, well, hey, questions? Hey, we're talking about infinity. I mean, this baffled the most brilliant minds on the planet for thousands of years. So if any of this isn't clicking with you, come to office hours, please. Go to tutoring. Whatever you need to do. You want to get this under your belt now, because hey, we're just building from here. So best of luck to you guys in the homework. That's it for 2.2. That's all I've got to say.